Hey, Jitin, this is Brett. I'm going to run you through how to create a synthetic tomogram with CellPack. I've tried this several times already, and every time I've done it, something has gone wrong, which is the state of the situation, I'm afraid. This stuff is not very well organized and defined. But hopefully this will work. Now, we have here a spreadsheet, and you can see there are headers on these columns. Those are important. And we have the PDBs and name, handle, and PDB. Just use the PDB file for all of those. And then molarity here, you can adjust as needed. See here we got BXR. Yeah, tell you what, I'm going to change this because I like having I don't know. Yeah, I'm not gonna do that. Okay, so 1A, 1S. I think this one I'll take down concentration. So, and you can add more PDB IDs as you want down here. Just include molarity. And this column is whether or not to include that ingredient, because sometimes you have a list of ingredients like we have here, but you don't want to do them all because you're just running a little test, or you want to cut one of them out. And so if there's something in this cell, anything in this cell, then it will include that ingredient, and if the cell is empty, it will be excluded. So we'll save this as GT5 now. And I hope I'm pronouncing your name correctly, by the way. I apologize if I'm not. All right, so we have a CSV file. Now, what we're going to want is oh crap, I'm going to have to restart this too. So yeah, my apologies once again. Yeah, it's late, I'm very tired, so my apologies in advance for sloppy presentation. So we need to create a mesh file that we can use as to define the compartment. And we're just going to do a sphere. Now remember, this is in angstroms, so right now the sphere is 200 angstroms across. I think it's across. I don't know, it doesn't matter. Yeah, it is actually. Oh, that's right, it's a sphere, so it doesn't matter. So we can pull it open, and let's make it around 800 nanometers, or 847, it doesn't matter. Does not matter. All right, going to the overlook here, and the reason we're doing this is because the folder, the mesh file, has to be in the correct octant. It needs to be in the positive X, positive Y, and negative Z octant. So we'll move that to here, positive X, positive Y, and I am leaving a little bit of empty space. It's going to fit in this 1000 angstrom cube. And then over here, we'll switch this to the negative Y negative Z direction, I'm sorry. And then that is our mesh file that we're going to do. So now, this is really critical, and this has actually tripped me up several times so far. We're going to save this mesh file, but right now it's named sphere, and it has to be named the same thing in Cinema 4D as the file name that you save it as. So we're going to call this, oh God, we're going to call it JSphere 5. Right, so that is what we're talking about here. Just to be completely safe, I'm going to, God damn it. I don't know. I was going to copy this. For some reason it's not working. I'm not too good with this thing. And we need to export as a DAE file. Right, and we're going to call it JSphere 5. We're going to put it in the Jitin 5 folder. And that should do it. Export triangles set. That should all work. All right. So here we have the compartment, and we have the CSV file. We're time to run CSV to recipe. So CSV to recipe, there's a couple of instructions up here at the top. And this is something that's kind of tricky. This old numeric folder has to be copied from MGL tools packages to your Anaconda library. This program runs under Anaconda, so it needs to be installed and you need to be using that as your interpreter. So you can see here, this is the NumPy folder, and this is MGL tools packages. And down here is the Anaconda library, Python 2.7, site packages, NumPy. So you just take this, you drag it into there. I'm not going to actually copy it. And then you're ready to go. My battery is going to run out. All right. Hopefully I'll be able to get through this. This is a PDB parser from BioPython. So that's something that you might need to download and install as well. I think all of the Collada stuff is in the MGL tools packages. And then I think CSV, that actually might be something you need to import as well, or it might be in, what do you call it, Anaconda. Anyway, and you need SciPy, but that's part of the Anaconda package, so that's no big deal. Now this path is very important because this has to be in the path. The MGL tools packages has to be in the Python path. So this will be your computer wherever you keep it there, but it's usually kept in the Maxon preferences folder, and I think you know how to get there. The model directory we saw before was Jitin 4, but now it's Jitin 5. The CSV name, also Jitin 5. The JSphere is actually JSphere 5 now. Let's just make sure that all of that is correct. Jitin 5, JSphere 5, Jitin 5 CSV, all looks good. Alright, bounding box, you don't need to worry about. None of this other stuff you need to worry about. And now we run the program. Alright, so what it's going to do is it's actually going to download all of the PDB files and put them here in this folder. You can see it's doing it right now. And it's building mesh files.
Beer time.
And it says beer time when it's done. And you see here the recipe, Jitin 5. And all of the ingredients and their course molecular surfaces, the PDBs are all here in these folders. And that's all you need. So you've got a recipe. So we'll start a new thing, auto pack. Now we always turn on debugging when we do this so that we can see if something goes wrong and figure out what it is. Go to Jitin 5 and open up that recipe. Bam, worked. Good. And auto pack goes over here or something. This to get rid of. Zoom back. We've got the bounding box on there, which I don't like, so I'm going to get rid of it. We have the sphere mesh here, which is important, but just want to show you. Oh shoot, it is empty. Okay, now we're going to pack it. Bam. All right, so this is now packed, and the colors are completely random, but and you know, they're sticking out. I mean, there are some improvements that need to be made. But I think this is why you need a little buffer on the outside, because you don't want it to stick out beyond the actual plane there. But there you go. So now you can take and save the result. And we're going to call this Jitin 5 recipe. So, but it's a result file. So we're going to say res. All right, now I've created 3 files actually, and the one you want is that one. So you can delete the other ones if you want, but that's the one that we're going to be working with. And now it's time to go into MATLAB. Now you are familiar with this thing. I call it Tomosimu Sandbox. And there are some things that I have added to it. You need this load JSON, JSON lab folder, and you need the Quaternion toolbox. And if you've got both of those, and a Tom toolbox, and all of this stuff, then you should be fine. I will send you this, and this is your special version, btomj, and so you should be able to use it. But if there's any problem, you got to make sure all the pathways are correct, and then all right. All right, I just had to plug in my computer because I was going to run out of juice. All right, so yeah, you can download both of these packages. I gave you the web address here. I don't know why this has spaces in it. I don't know if that's correct or not, but I'm sure you can find it. This has to be changed. Oh crap. Model directory, Jitin 5. And then this has to be changed. Also Jitin 5. And actually the rest of this stuff, pretty safe. Don't need to do anything about it, except for this bounding box. And actually, I'm not sure. I don't know what's going on anymore. But this bounding box has to be the correct size. Now, remember I set it for 1,000 angstroms, and this is nanometers, so that should do it. And let me just save this. All right. And now let's run the file. See what happens. Adding the particles. I only added 2 of the 1A1S because we reduced the concentration on that. And now it is making the MRC folder file. And there it is. We will change to terminal. Then we'll do imod and drag that in there. And please work. Yes, I think it worked. Fantastic. All right, and there we go. Well, I am so happy right now that I'm going to do a little extra bit. We're going to take this recipe, no, MRC file. We're going to drag it into Chimera. Criminy. Alright, maybe close this. And do it again. Why am I doing this? I don't know. You'll see. Now, you don't want to move this. I want to export the scene. I'll put it in Jitin 5. And I want to make a DAE. And call it, what was the file that we made it out of? Yeah, this is an MRC file, so let's call it this. This is how I like to name things. Probably not the best, but I don't know. What? No. Could have added. Ah, that's right. I gave the wrong suffix. Okay, here we go. And there we have it. Now, let's drag it here into Cinema 4D. That should be fine. And there it is. Now, there is an issue, usually, with these things, which is that they're 10 times larger than they should be, and that is probably because of the what do you call it? Scaling factor between angstroms and nanometers. So there it is, and the way to fix that is go down here, scale, and do 0.1, 0.1, 0.1, and apply. And now we're back. I'm going to get rid of the mesh, and we'll see how close we are. Not too bad. Now, there are still some things that need to be adjusted, but I will take care of that soon. Other than that, what you have is basically a density map based on the cell pack volume. So I hope this was useful for you. I am very anxious to hear all your feedback and input. Let's work together on this and make this the most awesome software package that we can. Feel free to contact me anytime. And that's it. Then take care. Bye.